Well, good morning, everyone. I'd like to welcome you all to this Infoblox webinar on revolutionizing the network and data center with IPv6 and DNS. My name is Tom Coffeen. I'm a distinguished architect here at Infoblox, but more importantly for our webinar today, I'm the IPv6 evangelist, and we'll be talking about some of the aspects of IPv6 and how they're going to impact data center provisioning and the network in general, whether you're building out a data center or maintaining one, or even just running a corporate LAN for an enterprise network. There's a lot of ways in which IPv6 is going to be impacting your operations, maybe impacting your operations today, but certainly will be impacting your operations in the future. So we'll cover some of those, and then we'll leave some time at the end for some Q&A, and hopefully we'll get all of your questions related to IPv6 and the data center answered. We're going to focus a little bit too on DNS today. It's a critical component, obviously, of any of the networking that we do. And with IPv6, there's a few things to consider related specifically to DNS around both security as well as related to how we're going to be enabling access to particular applications, whether that's over IPv4 or IPv6. And then there's also some technologies that we can use to deploy IPv6 in an IPv6 only environment in a way that leverages DNS and DNS 6.4 to allow us to do that and connect out to the rest of the IPv4 world that we need to maintain connectivity to. So the agenda, as we have it today, we're going to look at first IPv6 adoption in the US and globally. I like to start with sort of a picture of where we're at. If you're not paying attention to IPv6 from day to day or week to week, like the IPv6 weirdos in the IPv6 adoption community that I proudly count myself as a member of, then it's often a surprise to sort of see what's happening with IPv6, especially here in the US, just the overall levels of adoption. So we'll take a look at that as well as what's going on globally and sort of the direction things are headed with IPv6. And then we'll talk about some of the just general challenges related to data center provisioning. These may or may not apply to you, but it's certainly something that you'll want to keep in mind as we go through the presentation. And again, this presentation is focused on the data center, but a lot of the IPv6 information that we're going to be talking about here is related to just the network in general, whether it's the data center itself or a corporate LAN that you happen to be having to maintain and configure. Okay, let's see. It looks like I'm having some network connectivity issues, so I may need Heather to advance to the next bullet point here, which is addressing the IPv6 data center. So we'll talk a little bit about some of the addressing techniques that we have to use in order to use IPv6 as we address resources in the data center, servers, VMs, et cetera. And the addressing subject is something I talk a lot about just in general in dealing with IPv6, address planning in particular. There's a lot of different rules related to IPv6 when we build our address plan to address resources in the network and the data center, that if we just try to drag our IPv4 practices into the IPv6 world, we find that it's not going to work that well for us. We're going to end up not taking advantage of the tremendous capacity of IPv6 to address everything that we have and leave literally orders and orders of magnitude of addresses left over that we are not going to end up using, but it's not a reason to actually not take advantage of that large IPv6 space that we have at our disposal. And we'll talk about that and what that means. So let's see if I can restore my network connectivity here. On the next agenda item, we'll talk a little bit about securing the IPv6 data center. So IPv6, there's a lot of confusion around security related to IPv6, whether or not IPv6 is more secure or less secure. It's kind of a trick question. If you've been dealing with routed protocols and networking environments before and leading up to IPv4, then you kind of recognize that every routed protocol sort of has its advantages and disadvantages related to security. Having said that, with IPv6, we're going to definitely need to take a look at the way in which security is very particular related to the IPv6 protocol in the ways that we're deploying it today. And there'll be some issues around that we'll take a look at. So DNS and the IPv6 data center is the next item on the agenda. And we're going to talk about, as I mentioned before, using DNS as a sort of, first we'll just sort of do a brief review of IPv6 DNS so you can understand what's different about IPv6 DNS as compared with IPv4. And then we'll take a look at ways in which we can use some aspects of DNS to control access to applications, as well as taking advantage of the transition technology known as DNS or to allow us to build IPv6 only networks that are able to communicate with the rest of the IPv4 internet. So lastly, we'll look at some of the next steps. And basically, based on the information that you're going to learn in the webinar, we've got some steps that you can take related to some offerings that we have, and hopefully that you'll find those useful in your IPv6 adoption efforts. Let's see here. So, and then we'll leave some time for Q&A. Hopefully the presentation will generate some questions. I'm still struggling to get my network connectivity back here, so bear with me. So on the next slide here, IPv6 adoption in the US, we're going to actually look at a graph that shows you the level of IPv6 adoption. As we measure it, this is like sort of a standard metric that we use in the IPv6 adoption community to determine what level of IPv6 adoption we're seeing globally. And basically, it's just measuring how much traffic is hitting Google that's arriving over IPv6 as compared with IPv4. And as you can see from the graph, internet traffic to Google over IPv6 is sitting right around 20% today. Now, that's if you think about it just in the larger term, that's a pretty significant percentage of internet traffic that's over IPv6. But I think what's more interesting about the graph is just the fact that we're actually seeing a sort of S-curve, an exponential curve up and to the right for the overall level of IPv6 adoption. And we'll take a look at that again here in a slide that's coming up and sort of draw some conclusions about that. So next up, we'll look at the reason why we're seeing so much internet traffic to Google over IPv6, and in particular in the US, where we're actually at 35%. So if you look at the actual IPv6 operators that we have here in the US, actually just the network operators that are using IPv6 and leveraging it in their service offering, and they have to do this because basically they're running into an issue where the IPv4 address resources that they've used in the past, they can't get new IPv4 addresses because basically we ran out back in 2014 when Aaron announced that they were completely out of IPv4, routable IPv4 addresses. So if you want to continue to build and scale your service provider network, then you have to rely on IPv6, and that's what we're seeing here. If you look at the numbers, they're pretty remarkable. Comcast, which of course is a fixed broadband home internet, is sitting at 59%. AT&T is at 68%, and this is their internal traffic over IPv6. Verizon is at 83%, and they've actually dropped a little bit. T-Mobile is all the way up to 88%, which is just really almost an T-Mobile is at this point almost an IPv6 only network. And again, if you haven't been paying attention to IPv6, then that might be some surprising news. So then let's see here. We look at U.S. internet traffic to Google over IPv6. So a second ago we looked at the global traffic at 20%. Here in the U.S., the traffic that hits Google over IPv6 is sitting at 35%. That's a really remarkable level of traffic. And if you do a little bit, we can do a little bit of extrapolation here. We start with the U.S. population at 323 million. And then we look at U.S. internet penetration. It's hovering right around 70%. Number of internet users, that's right around 226 million then based on that 70% of 323 million figure. And then the percentage of IPv6 users that we're looking at on this graph, right around 35%. So you can probably see where I'm headed with this, which is 24% of the U.S. population is using IPv6, and that's around 79 million IPv6 users. So that's a pretty big number. At this point, we have 80 million users in the U.S. that are using IPv6. And we're not going to focus as much on it today in the presentation as to how that might be impacting your organization's business model if your content is not available over IPv6 and your competitor's content is available over IPv6. The fact that if you have a user that's coming from IPv6 trying to access IPv4 only content, that transition technology that sits in the middle has the potential to degrade user experience. So it's just something to keep in mind. Again, we're not going to dig into it deeply within this presentation, but something that may be impacting you related to IPv6. So worldwide IPv6 by 2018, we're looking at this, and so this is really, we're talking about, the end of next year. We're going to see a watershed moment, and maybe it doesn't happen right at the end of next year. This is a prediction based on Cisco's modeling. Somewhere in the late 2018, early 2019 timeframe, the overall level of traffic on the internet that's over IPv6 will exceed 50%. So that's a really, that's really a watershed moment for IPv6. At that point, IPv4 literally becomes the legacy protocol on the internet. And enterprises in particular have a sort of privileged situation where they can, as leaf networks, basically connecting to the internet at one location or a couple of locations, but internally relying on private addressing and NAT to continue to connect out to the internet and reach internet resources. They've been sort of insulated from this adoption of IPv6, and so you have some organizations that have started early with IPv6, some that have taken their time, and others that have sort of continued to put it off. As IPv6 becomes essentially the dominant protocol on the internet, it's definitely going to continue to impact operations in ways that, what we're going to talk a little bit about today, but there are also unpredictable ways in which you're going to be impacted by the fact that the rest of the internet is essentially, mostly IPv6 at that point, or a majority IPv6. So, but backing up, now that we've got sort of a picture of where IPv6 is at, both in the US and globally, just in terms of the overall levels of adoption, we can take a look at some of the challenges with data center provisioning, and we'll take a look at how IPv6 will impact those and potentially make things better for building out data centers, actually give us some improved practices for how we build out data centers. So looking at some of the challenges that we see in provisioning data centers, it's probably safe to say that most folks who are building out data centers, they're really challenged by, especially in multi-tenancy environments, the lack of unique IP addressing in IPv4. And so part of that problem lies in how we have a reliance on private IPv4 address space, because there's a couple of historical reasons for that. We've traditionally built out enterprise networks using private address space, so it's a comfortable practice for most folks. And so you end up sort of dragging that practice into the data center out of both habit and out of necessity, but then you run into issues, because basically with only three private ranges of private address space, you end up with the 10/8 range, 172.16/12 range, and 192.168/16 range. You end up in a situation where you have to reuse these blocks, and as a result of reusing these blocks, and especially if you're doing a multi-tenancy situation, you end up having to do things like natting between resources, or if you're lucky and you're doing things right, or if you're smart and lucky, that is, and doing things right, you can take advantage of technologies like VRF and really break things out in that way, in a much more manageable way. If you're unlucky or you're stuck with an environment that doesn't lend itself to that because of legacy technology, then you end up having to do a lot of natting. But of course, we've got some solutions to deal with that. NVGRE and VXLAN that give us the ability to actually do some overlays to work around this address range overlap, or the shortage of private addresses that we have at our disposal. But then the problem with that is that you end up having potentially a lot of additional configuration that you have to maintain, and doing the overlays. There's a lot of automation and orchestration that has evolved over the last several years that make that easier, but it's still always, overlays are always going to add complexity and potentially add brittleness to the network architecture. So in all of this, again, where you're just essentially trying to accommodate just not having the address space, so rather than having to deal with the complexity of managing overlays and adding another element to troubleshooting when you have performance issues that rear their heads, overlapping and insufficient ranges are going to create the challenges too, where you're trying to add, move, or destroy, recreate large numbers of VMs, which is the case in some data center environments. So, and then of course all of these solutions are exacerbated if you have, and just to mention containerization briefly, it's the same scenario that you have with VMs if you're building a large data center network where you're leveraging a lot of containerization. Again, the addressing stuff that's happening in the container environment internally, maybe that's not exposed to the outside world, but being able to address containers as they face the outside and being able to use unique addresses is incredibly valuable in terms of scaling up any offering where you're trying to leverage a large number of containers or VMs. So, one of the things that really makes this especially challenging is that we don't often think of having an IPAM solution in the data center. It often becomes an afterthought of how we're going to use IPAM to manage data center resources, and that's a function of a couple of different things. Some of it has to do with sort of the legacy thinking around IPAM being sort of a corporate LAN tool, but then also some of it is that a lot of the orchestration and automation that we're using may be attempting to do, we're doing address management sort of in an ad hoc fashion, and the hooks into an IPAM solution, maybe seem a little more complex, or there isn't really an off-the-shelf solution for orchestration and automation that we feel will work. So IPAM sort of falls by the wayside as a solution. And then, of course, that just complicates things even further because we're really trying to manage a resource that we don't have in abundance, which is the IP addressing, but we don't have an IPAM solution in place to facilitate that. So something as simple but critical as managing those address resources and device naming becomes essentially, difficult if not impossible. Okay, looks like I've lost my connectivity again, so I'm sorry, Heather, can I get you to advance to the next bullet point? And then finally, in the data center, as in the corporate LAN, we have the issue of having IPv6 addressing, IPv6 that's configured on modern operating systems by default. And this is a challenge of basically where, if you have an operating system that you've kept up with tech refresh and your operating system is, newer than 5 years ago, basically you have, as soon as you turn it on, it's enabling itself with IPv6, and it's enabling itself with at least a link local address. It may not have connectivity out beyond that segment or that switch port that it's connected to, but if you have multiple devices within a single subnet or VLAN, they can certainly talk to each other over those link local addresses. And the challenge then that we're running into is we see a lot of organizations that they don't have a mature IPv6 practice for tracking where IPv6 is and making sure that it's secure. And they're not really monitoring it, so they don't really know what's out there, what's running IPv6. So a mature IPv6 practice is about having the right tools for discovering and tracking those IPv6 enabled nodes. And you need to have that in place and not start from the assumption that, we're not really running IPv6, I don't have to think about it. So I'll talk a little bit now about how IPv6 is going to help solve the problem of addressing in the data center. And again, when we're dealing with this constrained resource of IPv4 and having to use private address ranges of IPv4 in the data center, we run into this issue of not having a sufficient address resource that allows us to configure all the devices, the virtual machines, containers, et cetera, that we're trying to run in the data center. And again, I mentioned multi-tenancy before. This is very much a problem in multi-tenancy environments where I want to be able to have tenants that have their own IPv6 address ranges to be able to use for whatever application they're using them for. If I have to hand out the same private address ranges to multiple tenants, then I'm back to a scenario where I have to do some sort of overlay or I have to use NAT. So first up on this slide for IPv6 address planning for the data center, I'll go through some just basic rules related to IPv6 address planning because again, as I mentioned before, a lot of us drag our IPv4 address planning practices into the realm of IPv6, and we've discovered that that doesn't really suit us well based on the tremendous abundance of IPv6 address space that we have when we're doing an address plan for IPv6. So I won't go into my usual level of detail. I actually wrote a book for O'Reilly that I'll show you later, so this is the topic that I love to geek out with the most, but you do need a few guidelines if you're going to talk about how to use IPv6 addressing for the data center. And the biggest potential problem for any deployment of IPv6, whether it's in the data center or not, is not getting a large enough IPv6 allocation to begin with. And so if you think about why IPv4 thinking creates problems for us in IPv6, it has primarily to do with this practice we have of treating individual host addresses as the basic unit of consumption, of address consumption. So, if you think about a /24 in IPv4, that gives us 254 host addresses, for instance, or we think about a /16 as giving us 65,000 host addresses. But we're very much sort of focused on this way of thinking about the number of host addresses we're consuming. So in IPv6, this metric, this kind of consumption metric, it's absurd and it's unusable. You can't use it because a single LAN interface is configured with a /64 and actually has 1.8 times 10 to the 19th host addresses. So obviously host address consumption can't be used as a metric. Instead of that, we use a /48 prefix as it, and this isn't everywhere, but in general, if we want to talk about IPv6 address consumption, I think the RIRs, the regional internet registries that hand out the IPv6 address space, are fond of using this metric. We use the /48 prefix as the basic unit of consumption in IPv6, and it happens that this is also the smallest routable prefix of IPv6 on the internet, and that can be critically important when you're choosing an IPv6 prefix to use for your data center. And what I mean by that is you've got a larger allocation of IPv6 and you're carving up smaller blocks to assign to functions or locations within your network. One of those locations is going to be a data center, and how much address space you assign to the data center, whether or not you use a /48 or larger or a /48 or smaller, you have to use at least a /48 if you want to connect that data center directly to the internet at some point. And that may or may not be an issue for you, but it's something to keep in mind. So if you look at the graph here at the bottom of the slide, it's actually showing you sort of the typical organizational allocation sizes. And you start off with the smallest allocation size that you're likely to receive from a regional internet registry, and it's right around a /44. Some enterprises got in early to IPv6, got smaller allocations, they got a /48. Generally, you don't get anything smaller than a /48 from a from a regional internet registry. But if you have more than one site, which we'll look at in a minute, that's actually not a large enough block because you should be assigning a /48 to a single site. So most enterprises are getting a /44 or larger. If you're a larger enterprise, you're probably getting at least a /32. And then, of course, service providers are getting much larger blocks because they have to actually hand out additional address space to their customers. So if we go to the next slide, we can look at the way that we can sort of plan for IPv6 in the data center by figuring out what size block we're going to use to hand out to data centers. And the way to think about the table that's on the slide is to ask yourself, how many sites do I have? Your sites might be physical sites like headquarters, campuses, data centers, or even small remote offices with just a few hosts. You can even define your sites logically based on routing domains or security zones. But by giving all your sites at least a /48, you're preserving plenty of space for future growth within a site, and you're also guaranteeing that you'll always be able to connect and route that site directly to the internet if you need to. Not always a requirement, but something that you can, a safety mechanism that you can build into your network planning if there's any question as to whether or not a site might be connected directly to the internet in the future, make sure that it gets at least a /48. So if you look at the chart here, it's really showing you there's basically 4 numbers that you have to keep in mind when you're doing your planning around how many address blocks you're going to need, how many prefixes you're going to need. And I use the 75% allocation rule here, which is what the regional internet registries use. And basically it just says if I've used more than 75% of the prefixes that are available in a particular allocation, then I should really be getting more address space. I need to jump up to the next level. So the first nibble boundary in IPv6, because each of those characters in the address represents a nibble, we sort of do our allocations based on nibble boundaries to keep everything tidy in the network prefix. So the first nibble boundary gives us a /44, which is 16/48. So then the question becomes, do I have more than 12 sites? Because that's 75% of 16. If I do, then I really should be getting at least a /40. And then the same logic applies there. That gives me 256 /48s. If I'm using more than 192 of those, then I really should be looking at a /36, 4,096 /48s, and then so on, all the way up to 65,000 /48s that I get with the /32. So that gives you the ability to do a little bit of basic planning to decide, first of all, if you start from that rule of thumb of using a /48 per site, you can ask yourself, well, how many data centers do I need to number? And of course, it's not just data centers. It could be your campus, your headquarters site, your regional offices, et cetera. You just sort of have to add all of those up, consider them sites, and then make sure that you ask for a large enough block from your regional internet registry so that you can address the data centers that you have and everything else, all the other resources in the network. And this is a huge advantage if you think about being able to assign a consistently sized subnet to basically a consistently sized prefix to everything that you have in your network. From a management standpoint, that makes things really simple, really easy to manage because you can start thinking about the network more logically as you're managing it instead of having to carve up all these little prefixes that, there's some over here, there's some over there. Some come out of this larger prefix, others have their own larger prefix. And over time, that may happen anyway with IPv6, but at least initially, you have the ability to keep an address plan super clean as long as you're not worried about wasting host addresses. So if we go to the next slide, the basic rules then for what to do as far as your IPv6 address planning for the data center and for your enterprise in general. Obtain what we call provider independent space directly from the regional internet registry. This is important to do because the regional internet registries are going to assign you a block that you can use for the duration of your organization's existence, as opposed to if you get an IPv6 address block from your service provider, that's what we call a provider assigned allocation, and you actually have to give that back if you change service providers, and you don't want to run into a situation where you've numbered your entire network into IPv6 and then you have to hand the addresses back over and totally renumber at some point. So you want to consider, as we saw from the last couple of slides, using a /48 or larger per data center. I've seen some of our larger enterprise customers with very large data center deployments use /44 or /40 per data center and not actually use those same large blocks everywhere else. It really just depends on the size of the data center that you're using, but just keep in mind the numbers. If you've got a /44, that's 16 /48s. If you've got a /40, that's 256 /48s. Those are pretty big environments as far as data centers go, but those are sort of numbers that you can keep in mind. And then again, using the nibble boundaries guarantees that you can improve the legibility of the network prefix. You'll always know when you assign a prefix on a nibble boundary, where that prefix lives, what you've assigned it to, and for operations purposes, it makes it very easy to track. So the operational efficiency that you get out of that is really good. And there's been some, it's just sort of habit that comes from IPv4 using unique local addresses, which is the equivalent of IPv6 private addressing. Because we use private addressing in IPv4, a lot of network architects and administrators who are new to IPv6 think, well, I'm using IPv4 private addressing, I'm using NAT, I want to do the same thing in IPv6 because I'm thinking about, the fact that no one can see the topology of my network addressing because I'm using NAT and I'm using private addressing internally. Well, the security value of that is basically zilch. If you talk to security experts, with all the malware that's inside networks today, all the ways in which people can get inside the network and exploit it, your IP addressing topology is not secure, whether or not you're behind NAT and you're using private address space or not. So with IPv6, we just recommend that you use global unicast allocation addresses, which are essentially public addresses. It doesn't mean they have to be routed out to the internet. You can still use stateful firewalls. You can still block all that stuff at the perimeter if you want to and need to, which you probably should be doing. But it's something where just because they're public addresses, they're not inherently less secure as long as you got the right security tools in place, and you're not adding an additional layer of complexity and brittleness with NAT, because again, we've had years and years for NAT 4.4 developers to build in fixes for the ways in which NAT breaks applications. We haven't had the same time to really bring v6 into the fold and fix all those applications in v6 land. So there's a great risk of having applications break and having NAT break those applications. And there's just really if it's not gaining us anything, then we shouldn't use it. Unique local addresses, if you're just doing internal addressing that never needs to connect out to the internet, for research environments, it's probably okay to use. But again, if you're planning on connecting to the data center to the rest of the network, the internet, then you want to use global unicast addresses. So then the other advantage that we have in IPv6, and it looks like I have network back here, so I'll take over control. We have prefix delegation, which we can do with IPv6. We didn't really have this function in IPv4. And to give you an example of what that looks like, I've got a DHCP server that's been assigned my overall organizational allocation of a /32. I just picked on the slash, so large enterprise /32. So this is within the data center. I can use prefix delegation, which is a way of automatically assigning a prefix to a downstream device, a downstream router. And in this case, I assign a /48 to my data center router. That's going to give me 65,000 /48s. That out of that my /32 is giving me 65,000 /48s. I assign one of those to my data center router, and then in turn that gets handed down to a top of rack layer 3 switch as a /56 out of the 256 /56s that are available in a /48. And then on that segment, whatever I'm running, servers, VMs, hypervisors, containers, whatever it looks like, a /60 delegation goes out, and I can address the devices on that segment out of that /60 delegation. But the cool thing about this is all that upstream delegation can be automated. And again, this is something that as a data center provisioning practice, we don't have a lot of examples of it yet, but it's something that's certainly feasible, and we may want to keep our eye on this as a way to make data center provisioning of IPv6 addresses much more manageable and automated. So if we go to the next topic on the agenda, which is securing the IPv6 data center, as I mentioned at the top of the presentation, we have an issue with the fact that IPv6 is on by default in all modern operating systems. So it doesn't matter what you're running in the data center, and for that matter, what you're running on the corporate LAN. As soon as you enable most modern operating systems, all modern operating systems rather, IPv6 is enabled by default and will configure itself with at least a link local address. It also may attempt to configure itself with a global address if it sees a routing advertisement on the segment, but of course that's something that you have to configure explicitly. But this is one of the things where if you've come to IPv6 late, you have what we like to call a bit of a late adopter advantage. If you'd started adopting IPv6 back in 2009, 2010, there was still a lot of variance in terms of the level of support that you saw for network operating systems or for operating systems, the network pieces of those. The fact that you just didn't have the right kinds of robust support for IPv6 in all cases for all deployments. And that manifested in different ways. Protocols like DHCP, which we'll look at a little bit later in the presentation, were not as mature as they are today in terms of the operating system deployments for them. And in fact, IPv6 has been such a critical part of modern operating systems that Windows in particular, Microsoft in particular, doesn't allow you to disable it without telling you that you're out of scope for support, that you're running basically an untested, unvalidated environment as far as their support level is concerned, and they can't guarantee that whatever solution they provide you will fix your problem until you re-enable IPv6. And there's a couple of different reasons for that. They're using some of the services that they use, like Windows Server clustering, take advantage of IPv6 on the back end. So again, just going in and turning it off is not an option. So from a security standpoint, that's often the first reaction. It's like, well, we're running IPv6. We don't want to be, so let's just go ahead and disable it. You may or may not be able to get away with that. Just be aware that you're potentially breaking your access to support over Windows if that's your approach. So really, rather than take that approach, we need to be looking at how to learn what IPv6 is running on the network and manage it effectively. We have some tools that allow you to do that. Infoblox has a network insight component that goes out and discovers IPv6 nodes that are running on the network automatically. So something to keep in mind. One other thing to point out here is when you start, we'll talk a little bit about auto-addressing here in a moment, but when you start auto-addressing in the data center, you can choose between DHCP and SLAAC. Basically, SLAAC is the IPv6 auto-addressing, the auto-addressing that's built into IPv6, whereas DHCP is the v6 update to DHCP v4. It's actually written from the ground up, so it's its own protocol. So some of the challenges, we'll talk more about that in a second, because there's challenges in terms of which one you pick, how you're going to manage those IPv6 addresses that you allocate. But something to keep in mind is that Android doesn't have DHCP v6 support. So we've got an ability to support handing out DNS information in SLAAC and IPv6 auto-addressing that's built into the protocol. That's supported by Windows and OS X. But we don't have support on Android for DHCP v6. So that means that in corporate LAN environments, you end up potentially having to run both DHCP v6 and Slack just to support Android, which is annoying, but that's kind of where things are at. If you're running Cisco switches, other folks are providing the same functionality. I think Juniper has this function as well. In any case, there's something called first hop security, and this gives us the ability to make sure that we're securing segments so that we don't have the potential of a hacker or a black hat using the auto-addressing function of IPv6 to launch like a man-in-the-middle attack in this example. So if you're familiar with DHCP snooping and IPv4, it's very similar to that, and the concept is really simple. You know, if I have a target node here, he wants an address to get on the network. He's sending out a DHCP v6 solicit to the multicast all nodes address. The link locally scoped multicast all DHCP nodes address. So he's sending out that solicit, and then what happens is the server responds, which is what we want to have happen with the DHCP v6 advertisement, but the server has left its preference at the default of 0, and the server offers this address. And meanwhile, we've got a hacker on the network, a rogue DHCP v6 server that sets its preference higher, so we end up with the target configuring its address, but more importantly, configuring its DNS server to point to the rogue DHCP v6 server, which means all of the traffic can then be pointed from the target to the rogue DHCP v6 server. So if you're familiar with DHCP snooping, you know where this is going. Basically, I make sure that I have a port configured on the switch that allows that DHCP v6 advertisement for the legitimate DHCP v6 server, but then blocks it for the rogue DHCP v6 server. So you've got this built into first hop security, built into most of your updated Cisco switches. It's something that you can enable today. There's the DHCP v6 component. There's also the RA guard component, which does the same thing for Slack for router advertisements, so that unless I have a router connected to that switch port, I'm not going to allow it to send out router advertisements and potentially do this man-in-the-middle attack. Something to keep in mind. We'll talk about DNS in the IPv6 data center. A brief DNS review related to IPv6 DNS. It's not complicated. Basically, 2 new elements were created to support it. We have the equivalent of an A record in IPv4, the so-called quad A in IPv6. It just allows us to forward map domain names to IPv6 addresses. And for reverse mapping of IPv6 to domain names, we have the IP6 ARPA domain. But this is where it gets cool in that you can use DNS as basically just a big on-off switch to determine whether or not you're going to allow nodes that have configured themselves with both IPv6 and IPv4 to reach out to either IPv4 resources, services, applications, etc., or IPv6 resources, or a mix of the two. So basically, I can publish a URL, a domain, a subdomain that's specific to IPv6, and I can control the traffic that's going to that service over IPv6 by using DNS to turn it on and off. And this is really useful in instances where you have resources, they're never going to support IPv6. You may have applications that are, were coded back in the dark ages, and there's just simply no way to upgrade them so that they support IPv6. They're always going to be on IPv4. They can certainly function potentially in a dual stack network environment because IPv4 is supported, but you can make sure that those services never publish an IPv6. They never have a forward map name from the domain to the IPv6 address, so that resource is only ever accessed over IPv4. Another technology we can take advantage of in the data center, especially if we want to do an IPv6 only data center deployment and take advantage of all the ways in which IPv6 address provisioning gives us basically an unlimited supply of that resource and not have to deal with IPv4 at all in terms of management. DNS 6.4 gives us the ability to do that. It's a little bit complicated how it works, but basically the slide will walk us through it. Basically, you have in the network here, you can see I've got my data center. It's IPv6 only, but I've got a recursive name server that's running DNS 6.4. And so what happens is the client sends a query for www.ipv4only /quad A. So that's going to the local recursive name server. So that recursive name server is going to go ahead and send the www.ipv4only.com/quad A query to the next name server response because it doesn't have an IPv6 address record for that domain. So it also sends back just the /A record, basically the v4 mapping because it has a positive result for that. Then the next step is using the 64:FF9B:/64 prefix. This is reserved specifically for DNS 6.4. The recursive name server synthesizes an IPv6 address to return to the client in a quad A record. So it reached out to the recursive name server, didn't have an IPv6 record because there is no resource configured with IPv6 out there on the internet for that resource, only v4. So we're basically going to spoof that by using this v6 block and synthesize a quad A record that we send back to the client. The client then sends the packet with the synthesized IPv6 address, and that routes to the NAT64 protocol translator, which sends it on its merry way to the actual IPv4 only resource. And then, of course, the traffic on the way back gets translated back to IPv6, and basically you have a mechanism that allows you to reach those IPv4 only resources from an IPv6 only node that's configured inside. So again, I won't beat up on the topic of not doing NAT 6.6. This is very different, a very specific application where I want to do IPv6 only in the data center. That's not the same thing as running NAT 6.6 with ULA private addressing internally. So that's DNS 6.4. If you want to run an IPv6 only data center, you know, even something that you might want to do as a test case, you can certainly do that and use DNS 6.4 along with NAT 64 to support that. DNS 6.4 is built into the Infoblox NIOS platform so that we can actually support that configuration. You will need another vendor to provide the NAT 6.4 component for that. So then getting on to what the recommendations are, then sort of encapsulating a lot of what we've talked about here today, recommendations for deploying IPv6 in data centers. Basically, as I mentioned before, and I can't beat up on this enough, you really need to just make sure you get a large enough IPv6 allocation so that you can have large enough blocks to allocate to your data centers. There's just no reason to attempt to conserve IPv6 addressing. Consider using at least a minimum of a /48 per data center, maybe more if you're doing multi-tenancy and have customer allocation requirements for IPv6 addresses, but at least a /48. As we saw, there's potentially some security issues. You don't want to forget about security for IPv6. Make sure that your existing network management tools, as well as your firewalls, your IDS, your IPS, support IPv6, that they have visibility into IPv6, and that and especially with stuff that you're doing security at line rate, you want to make sure that all of that IPv6 functionality is built into hardware as opposed to software. It's not as much of a problem as it used to be, but some of the early security middle boxes had that issue with IPv6 as they are with IPv4. But you definitely don't want to forget about security. Also, having a tool that does IPAM, and especially having that IPAM tool have a network discovery component built into it that can then load that information back into the IPAM database. That's certainly something we offer with Infoblox, and it's something you should take advantage of. So making sure that IPAM solution is giving you visibility into the addresses that you have configured in the network in the data center, and preferably one, as I mentioned, that integrates tightly with DHCP, DNS, and network discovery. So next up, you want to make sure you can use DNS, as I mentioned, to control access to IPv4 only, dual stack, and IPv6 only applications, services, resources. Just basically use it as a big switch to either enable connectivity. So if I have a node that's dual stack, it's configured with IPv6 and IPv4. If it's not going to try to access a resource over IPv6 if it doesn't get a quad A record forward mapping from a domain name to an IPv6 address. So if I want to make sure that I leave that transaction over IPv4, I can use DNS to do that. Very useful to control the amount of IPv6 traffic that we're turning on in the network, especially as we get started with it. And then finally, if you're integrating with a cloud provider, a lot of folks are trying to move IT workloads into the cloud, and there's different ways to do that. If it's a software as a service provider, it probably doesn't matter if the transport's over IPv4 or IPv6. On the back end, they might be doing the software as a service provider might be doing things with IPv6, but maybe that's only a concern if you're trying to do infrastructure as a service. If you're actually having to have components that are interacting with cloud components over IPv6. Your mileage may vary. Just be aware that, like with Amazon AWS, they just added EC2 support, IPv6 support for EC2 rather, very recently. We've had IPv6 support for Elastic Load Balancer for a while. CloudFront and WAF and S3 have supported IPv6 for a while as well. So Amazon is pretty committed to enabling IPv6. Again, you know, Amazon AWS network environments are a little strange and finicky, and you can definitely expect a lot of headaches, just like you get with IPv4 as you're turning up networking in that environment. It doesn't behave like an on-prem network, but there is some IPv6 support there. Same is true with Microsoft Azure. We've got support for VMs and for Azure Load Balancer, so there's some IPv6 support there as well. The question then really becomes, depending on what orchestration or automation tools you're attempting to use, what APIs you're attempting to use, depending on what your cloud deployment looks like. You know, some of those components have really good IPv6 support, some of them don't. It's getting better, but it's definitely something where you want to do your homework. And then, of course, we don't have Google support. We don't have Google Cloud support yet for IPv6, which is disappointing, but that's where we're at. I assume that they're working diligently to get it added because they don't want to get too far behind Amazon. So then, finally, next steps. We talked about the IPv6 addressing plan challenge. If we're still thinking about IPv6 in terms of IPv4, and again, I can't state how critically important this is to just making sure that you don't paint yourself into a corner by getting too small of an allocation rather up front. You want to make sure you get a sufficiently large IPv6 allocation from your regional internet registry, a provider-independent allocation that will follow you, and you can use it anywhere, you know, for the rest of the organization and network's lifetime, as opposed to address space that you have to hand back over. But we've got this really cool free tool called 6map, and it basically, what we talked about with having like a network that, you know, we think about our network in terms of functions and locations, you know, data centers, headquarters, remote offices, et cetera. 6map will carve up out and gives you like a very nice pictorial graph of that. And actually, I'll just scan forward here to the tool so you can see an example of it. That's the primary interface. It's super simple, easy to use, it's free, and then at the end of it, you can print out a PDF that shows you what the actual IPv6 address plan looks like. It's a very high level and super straightforward, but it's certainly helpful for sort of showing folks what an IPv6 address plan should look like. So then also Infoblox IPv6, infoblox.com/IPv6. We've got a ton of IPv6 resources to help you with your IPv6 adoption effort. White papers, solution notes, videos, webinars like this one, guides. We're doing a podcast now, and we have a regularly updated blog by our technical advisory board members, myself, Ed Horley, who works for Groupware, is one of our partners. He wrote the Windows Administration for IPv6 book on A-Press, and then Scott Hogue, who wrote the IPv6 Security book for Cisco, is also on our technical advisory board. Smart guys, really into IPv6. They have a lot of information to share. And then we do a lot of industry thought leadership around v6 adoption and make sure that we're, you know, making sure the product is supporting IPv6 in all the ways that it needs to. So sorry, I have to go back and forth here. You'll want to evaluate Infoblox DDI if you haven't already. You can see the ways in which v6 support is baked into the product, and you can contact Infoblox to set up that demo. And then, of course, if you really want to just bore yourself silly with the IPv6 address planning topic, I've got a book on O'Reilly Media that digs into all the gory details about building your IPv6 address plan or rebuilding it, as I did with my first IPv6 deployment many times. I can't guarantee that if you read the book, you won't have to redo your IPv6 address plan, because address plans are always a work in progress. But I can guarantee that you won't make all the same time-killing mistakes that I made. That the book will help prevent from having that happen. So that's really it. That's all I had for the topic today, and I hope it was useful. I hope there's some nuggets of information that you can take back to your own organizations and figure out what the next steps are for you for IPv6. And thanks for attending, and we'll take a look at some of the questions here and see if I can get some of the questions answered. So let's see. The first one I have here is, I have data centers in other international regions. Do I need IPv6 addresses from those regions? Okay, this is really a great question, because in v4 land there was always the concern that we couldn't use our IPv4 public address ranges that we were using, that we got in one region in another region. So let's say I got a block from Aaron, and I wanted to route that that same address prefix in Asia. Some Asian service providers would not accept an allocation from another region, an allocation that had been assigned by a rear from another region. So if I got my address block here in the US, I couldn't use it in Asia, and potentially vice versa, depending on who the service provider was. The good news is with IPv6, out-of-region announcements are being allowed currently, and it looks like that's going to remain the case. So that means that I could potentially use my ARIN block everywhere. So if I get a /32 from ARIN, the regional internet registry here in the US, I could carve it up and use it globally. It doesn't guarantee that, down the road there might be some service provider that decides that they're not going to honor that out-of-region announcement, but I haven't heard of any instances of that happening. If you have a very potentially risk-averse enterprise, like a financial institution, you may want to consider going ahead and getting an IPv6 allocation in those other regions. It's super easy to do, and it may save you the problem of not having the ability to route those blocks if down the road somebody decides that they're going to be weird about it and not accept those out-of-region announcements. So let's see, what else do we have question-wise here? Is it better to use Slack or DHCP-v6 to automatically address devices in the data center? Well, that's really a tricky question because it really depends on the level of sort of automation and orchestration that you're already doing in the data center or that you plan to do. If you're trying to just use sort of off-the-shelf products to build out your data center, I would probably recommend DHCP-v6. The reason for that is that, again, if you're using an IPAM solution like Infoblox, you've got tight integration between network discovery, DHCP-v6, DNS, all of that, which you can then use to manage the resources in the data center environment. If you've got a lot of homegrown automation and orchestration tools that you're using in the data center and you're doing a lot of DevOps, and you're already, in that instance, if you've thought about deploying IPv6, you may already be using Slack in that environment. But again, Slack doesn't really give us the same hooks that we have with DHCP-v6 into being able to track nodes. So, I have to literally log onto the layer 3 device and scrape the neighbor discovery cache to discover what devices are on a particular segment if I'm using Slack. And maybe that's not a big deal if I'm scripting everything, but it's definitely another level of work. So again, depending on the data center environment that we're talking about, DHCP-v6 with a good IPAM solution, is definitely something I would want in my own data center deployment. Let's see, what else do we have here questions-wise? So this is one that's going to come up forever as long as we're moving until IPv4 goes completely away sometime down the road after I've retired. Isn't there a risk of running out of IPv6 addresses just like we did with IPv4? And the unequivocal answer to that is no, it's not going to happen. Now, I'll provide an example here that I first heard from, and not to be a big name dropper, but Jeff Doyle, one of my networking heroes who wrote the routing TCP/IP book for Cisco Press. I saw him at a conference once, and he gave this example of using that metric of consumption of a /48. He just did a little bit of calculation. He said, based on how quickly we're consuming /48s in the current global unicast allocation, if you flash forward to the year 2100, when there's 15 billion people on planet Earth, assuming that we get there, you still have enough /48s left over at that point at the current rate of consumption that you could give every person on the planet 2,200 /48s. And this is in 2100 with 15 billion people on the planet. Now, that's only out of the existing global unicast allocation, which is 2000/3, 2000:3. That's only 12.5% of the overall available IPv6 address space. So even if we totally bungled things and burned through IPv6 in the global unicast allocation that we have now, we could still just have another global unicast allocation assigned, another /3, another 12.5%. We'd still only be consuming a quarter of the overall address space at that point, and we'd be off to the races. The epilogue to that Jeff offered, and I think I've heard other networking giants like Dr. Vint Cerf make this argument as well. If you think that we'll still be using Internet Protocol in 20 or 30 or 40 years, then they say a bridge to sell you, because the Internet Protocol has been incredibly successful. It's simple and extensible in certain ways that make it, that's given the huge success story that we have with Internet Protocol to this point, IPv4 and IPv6. It's very likely that we'll see Internet as each other that probably won't involve IP addressing at some point in the future. Now, certainly not in 10 years, probably not in 20 years, maybe closer to 40 or 50 years, but we're just not going to run out of IPv6 before then. All right, it looks like those are all the questions that I'll be able to get to. There's a couple more on here that look pretty interesting, but all right, hopefully that was useful information. And again, thanks for attending. Look out for the next IPv6 webinar that we do here at Infoblox, and then any of the other webinars that we have around DNS security, cloud offerings, technology as it's evolving. It's keeping us all on our toes, and we're here to help keep you on your toes as well with that technology. So thanks again for attending, and have a great rest of your day or evening, depending on where you're listening from.